Alright y'all, I'm going to try and make a quick video of me going through the practice test in case you guys need some help with this. So, first thing I know about these two angles is that they are same side exterior angles. So that makes them supplementary. So what I'm going to do is say that 93 plus x plus 44 equals 180. And then if I had to give my reasoning, I would by saying that they're same side exterior angles. Next thing I want to do is combine my like terms. So 93 plus 44 is going to be 137. And I also have the x plus that equals 180 still. I'm going to subtract 137 from both sides. And I get x equals 43. For number 2, if I were to draw this sideways, it would look like this. And what we're saying is that this line is parallel to this line, meaning that these two angles, the x over 2 and the 7x right there, that they are same side interior angles. So that means that they're supplementary. So what I'm going to do is say 7x plus x over 2 equals 180 because they are same side interior angles. Now I don't like this fraction, so I want to get rid of this division by 2. I'm going to multiply every single term by 2. So 7x times 2 is 14x. X divided by 2 times 2, so let me actually do this, times 2 times 2, 7 times 2, 14, x divided by 2 times 2, what happens is that they cross off, and I'm just left with an x, and then 180 times 2 is 360. Combine the like terms, 14x plus another x is 15x, and then I'm going to divide by 15 on both sides, and I get x equals 24. This one's a little tricky. What you have to realize is that if these two lines right here and here are parallel, then this angle and this angle right here are alternate interior angles, meaning that they have the exact same measurement. Now, I don't know what this angle is, so what I'm going to do is say that this has a measurement of 2x minus 75. Then what I see is that all three of these angles right here add together to form this straight line. So what does that mean? They're supplementary. So I can say that 2x minus 75 plus 2x minus 20 plus x plus 35 all add up to be 180 degrees. Now if I combine like terms, I'm going to have 2x plus x, which is 5x. Negative 75 minus 20 plus 35 is going to be a negative 60. Let me add 60 to both sides. I get 240. And that's equal to the 5x over here, meaning that the negative 60 crosses off. Divide by 5, and I get x equals 48 degrees, or 48, not degrees. Next, what I want to do is go through each angle and tell the reason that it is the angle measurement it is. Now, if this is 150, I can see right away that angles 1, 3, and 6 are going to be 180 or 150, excuse me. So I'm going to go ahead and write that angle 1 equals 150, and the reason is that because these two angles are corresponding. Sorry, my handwriting is bad at this low resolution. And then I know that angle 3 is 150. And that's because it is alternate interior angles to that one that's given. And then angle 6 equals 150 because it is vertical to the 150. Or the one that's given. Now we have to go through and we have to get angles 2, 4, 5, and 7. Now angle 2 has to equal 30 degrees. I'm going to put degree measurements all on these because it is supplementary to angle 1. Angle 4 has to equal 30 because it is the same side interior angle to the given. Right here, these same side interior angles, or you can say that it's vertical to angle 2. Either way is fine with me. Angle 5 equals 30 degrees because it is supplementary to the given. These two supplementary. And then angle 7 equals 30 degrees because that is also supplementary to the given. Alright, what we know with these triangles, first of all, we know that each of these angles inside the triangle have to add up to be 180 degrees. What we also know is that this angle and this angle, the 137, and this unknown angle, I'm going to call it X right there, have to add up to be 180 because they form a straight line. That's the first thing I'm going to figure out. What is X? 137 plus X equals 180. And then I subtract 137, subtract 137, X equals 43. So I know that is 43 degrees right there. Now, these two are the non-adjacent interior angles to this exterior angle. And what we know is that this, we'll call it Y, is equal to these two angles added together. So Y is equal to 43 plus 102. And that equals 145. So that is our answer. If you don't like doing it that way, what you can do is say to yourself, alright, if I know this is 43, this is 102, I can find this angle. When I find this angle, I can subtract it from 180. So let's do that. Let's say 43 plus 102 plus, we'll call this angle Z, equals 180 degrees. Now 43 plus 102 is going to be 145 plus z equals 180. Subtract 145 from both sides, and z will equal 35 degrees. If you know that z and y have to add up to be 180, subtract 35 from both sides, and you still get y equals 145. So I find it easier just to do this method. Find the two inside angles that are not adjacent to the exterior, add them up, and you'll find it. I know the angle 1 plus the 72 degree angle plus 86 degree angle have to add up to be 180. When I combine my like terms, I have angle 1 plus 158 equals 180. Subtract 158, and angle 1 is going to equal 22 degrees. Now, if angle 1 equals 22 degrees, angle 2 is also going to equal 22 degrees because they are vertical angles. They're always going to be congruent. So that's easy. Next, we have to figure out what angle 3 is. So if that's 22 right there and there, what we know next is that 22 plus 70 plus angle 3 equals 180. So we're going to do this all over again. Angle 3 plus 22 plus 70 equals 180. Combine 22 and 70, so you get angle 3 plus 92 equals 180. Subtract 92 from both sides, and you get angle 3 equals 88 degrees. We're given these two angles, and we need to find C. That's easy. It's another angle C plus 44 plus 53 equals 180. Combine the like terms, you get angle C plus 97 equals 180. Subtract 97, angle C equals 83. Now, if I know 83 for C, I can find B. Why? Because together they form this straight line right there. So I can say angle B plus 83 equals 180. Subtract 83, and I get angle B equals 97, which is the sum of the two non-adjacent interior angles, if we're calling this exterior. And then we need to find angle A. Well, so I'm going to kind of separate this a little bit, just because I have a little bit of room left. And I know if that is 97, then I have angle A plus 97 plus 28 equals 180. Put the 97 and the 28 together. We get angle A plus 125 equals 180. Subtract 125 from both sides. You get angle A equals 55 degrees. Let me just take a look at my answer key here, make sure I'm correct about that. Good. What is the name for a triangle with one angle larger than 90 degrees? Larger than 90 degrees is an obtuse angle, so that would be an obtuse triangle. We need to solve for x. This is another one where we say all three angles inside the triangle add up to be 180. So I can say that 55 plus 54 plus x plus 74 equals 180. Combine, combine, combine. You still have x, but we have plus 183. And that's equal to 180. Now this may look weird, but it doesn't matter what x is. We're solving for it. So subtract 183. Crosses off. X equals -3. What is the sum of the interior angles of a dodecagon? So we know that the interior angle sum equals n, the number of sides of the whatever shape we have, minus 2 times 180, right? Dodecagon is 12 sides. So it's equal to 12 minus 2 times 180. 12 times minus 2 is 10 times 180. That's going to be 1800. How many sides does a polygon have if its interior angle sum is 1260? Well, let's see. We're going to use the same equation right here, and we're going to plug in what we know. This time we know the interior angle sum. So we're going to say 1260 equals some number minus 2 times 180. I want to get rid of the multiplication by 180 by dividing on both sides. Crosses off over here, so I still have n minus 2. And then 1260 divided by 180 is 7. Solve for n by adding 2 to both sides, and n equals 9. 9 sides. How many sides does a regular polygon have if its exterior angle is 12 degrees? So exterior angles, we know that the sum of the exterior angles have to add up to be 360, right? So we divide it by the number of sides to get the exterior angle. In this case, we're given the exterior angle is 12 degrees. So, what some people have done before in the past is put this over 1 and then cross multiply. So you get 1 times 360 is 360, and that equals n times 12, which is 12n. And then divide by 12 on both sides, and then you get n equals 30. The easier way would have been just to go from 360 over n equals 12. Flip these two because you end up dividing 360 by 12. So you just say 360 divided by 12 equals n, and you still get 30. Sorry, I didn't finish writing my answer. So 30 sides. Write the equation for the line described. The line with the slope of 6 containing the point -3,5. It's easiest if we're given the slope and a point, put it in slope point form or point slope form. So it's going to be y minus y1 equals m times x minus x1. So right here we are given x1 comma y1. That's where the x1 and y1 come from, and the slope, that's our m. So we're just going to plug in m being 6, x minus x1 is -3, and then y minus y1, which is 5. If I simplify this a little bit, I am going to make this double negative turn into a positive. So I have y minus 5 equals 6 times x plus 3. And I can just leave it like that. I didn't ask for any type of line or any way to write it, so just leave it in point slope form and you are done. The line perpendicular to 2x plus 17 containing that point. So we're going to put in point slope form, but we have to find the slope that would be perpendicular to a slope of m. Excuse me, of 2. I'm doing it this at midnight, so I'm kind of tired. Perpendicular would be the opposite reciprocal. So the reciprocal of 2 is 1/2. The opposite is -1/2. So that's going to be our new m, and we have this point. Same thing over. Y minus y1 equals m times x minus x1. We're given our x1 and our y1. Our m, our slope, is -1/2. X minus 8. Y minus -1. Make it plus 1. -1/2 times x minus 8. Leave it in point slope form because I don't ask for anything else. Line containing those points, well, I don't give you a slope, I give you some points. So what you can do is find the slope between those using the slope formula. So slope is equal to y2 minus y1 over x2 minus x1. So we're given x1 and y1 right there, and then x2, y2 right there. So if we plug in, y2 is 1, and we're subtracting y1 is 4, over x2, which is -3, minus x1, which is 6. 1 minus 4 is -3. -3 minus 6 is -9. -3 divided by -9 is the same thing as 1/3. So now we have our slope. And we have a point. We can use this one or that one, really doesn't matter. Let's use this one and plug it into point slope form. So we have y minus 4 equals 1/3 times x minus 6. Either way is good with me. Determine whether the lines are parallel, perpendicular, or neither. So we have to figure out the slope of each. This one, we know it's 1/3. This one, we're going to have to convert. So what we always do is take whatever our x term is and move it to the other side by making it its opposite, or subtracting or adding, depending on whether it's positive or negative. I have y equals negative 3x plus 2. Now, if this slope is negative 3 and this slope is 1/3, are they opposite reciprocals? Yeah, they are. So therefore, they are perpendicular to each other, or if you want, you can use the perpendicular sign, just like that. Now, these two, we're given the slope is negative 4 on this one, easy. All we have to do is convert this one to find its slope. So we have 4x plus y equals negative 3. Bring this 4x over, make it negative 4x. Bring the negative 3 down, and we have y all by itself. We don't have to divide by anything. We now have the slope of the second line, and it's negative 4 as well. Since they are the same slope, they are parallel. So, and you can write parallel, or you can give me the parallel symbol, just like that. Graph these lines. Well, they're in slope-intercept form, or this one is at least. We know the intercept, the y-intercept. It's at negative 1. So on the y-axis, we're going to go to negative 1, put a point, and then we're going to use the slope to find the next point. So 3 over 5 means up 3, and then over 5, 1, 2, 3, 4, 5, and then up 3 over 5, and we keep on going like that. And I'm just going to draw kind of a terrible line, sorry about that, but as long as it goes through a couple sets of the right points, I am fine with it. Now this one we're going to have to convert to slope-intercept form. So if we have, and I'm going to do that down here below the graph. So if it's 3x minus 6y equals 24, I'm going to subtract 3x from both sides to move that x term to the right side. That crosses off. I still have negative 6y equals negative 3x plus 24. What a lot of people will do is try to actually put these numbers together. They're not like terms. This has a term with x. This is just a number. Next thing you have to do, after I create some space for myself, is divide by the y coefficient. So I'm going to divide every single term by negative 6. Crosses off. I have y equals negative 3 over negative 6 is the same thing as 1/2 x, and then 24 divided by negative 6 is negative 4. So now I have my y-intercept and my slope, and I can go to town. Negative 4, and then I have slope of 1/2, so going up 1 over 2, up 1 over 2, up 1 over 2, and so forth. And I'm going to draw another terrible line, but it's going to look okay because I drew a couple of those points in. Now I have the last one, the hardest one here, is proving this. I like 2-column proofs just so I can see everything. If you want to draw a flow chart, that's fine too. But I have to prove that angle 1 and angle 3 are supplementary. The first thing I always do is make my chart here. with my statements and my reason, and then I always write down my first statement, or my given statement first. So L is parallel to M, and that is given. Now I'm trying to prove that angles 1 and 3 are supplementary. What I'm looking for is an intermediate that kind of connects 1 and 3. Looking for an angle that has a relationship of congruence to 1 but supplementary to 3, or maybe the other way around, congruence to 3 and supplementary to 1. I had some people ask me a question about this earlier, and they said that they wanted to use angle 2. So what you see is that angle 1 is congruent to angle 2, and that's because they're corresponding angles. They're in the same position relative to these intersections right here. So angle 1 is in the upper right, angle 2 is in the upper right. And if you want to write the theorem, it's corresponding angle theorem, stating that if we have two parallel lines, then the corresponding angles will be congruent. Next, we see it's obvious that angles 3 and 2 are supplementary. So I'm going to write that mathematically by saying that angles 2 plus angle 3 equals 180 degrees, because they're obviously supplementary, and the reason would be definition of supplementary angles. If you just want to put supplementary angles, that's fine with me. Next, what we know is that if angle 1 is congruent to angle 2, we can substitute angle 1 in for any equation into angle 2's spot. So angle, let me move it down just a little bit. Angle 1 plus angle 3 equals 180 degrees, because what we did was substitution. And there we have it. Very few steps in between. Alright people, good luck.